Hi everyone, this will be your video for basic trig ratios for right triangles only. So some basics that are understood that you should know from the past. The first thing is that all angles in a triangle will add up to 180. So no matter what type of triangle, if it's right or if it's any other type of triangle, it's all going to add up to 180. So your angles will always add up to 180. This is a major fact that is just assumed that you understand because it is used in a lot of problems. The second basic that hopefully you also remember is our Pythagorean theorem. Pythagorean theorems are specific just for right triangles. That's what this note down here says. Pythagorean theorem helps us find the different side lengths. Remembering that C is our hypotenuse, meaning that's this longest side. It's the side that's across from the right angle. So here we go. We're going to use these basics. We're going to use it with some new information on the next slide. So here we go. We have trig ratios for a right triangle. And I know there's a lot going on this page, and this is something that's great if you pause, write this down in your notes, but we're going to kind of figure out what's going on here. So when we're looking at a right triangle, and I'm going to draw a new one down here. If we're looking at a right triangle, there's a couple characteristics we want to be careful about. If we have a right angle, obviously we would if it's a right triangle, the opposite side is the hypotenuse. Okay, so the hypotenuse is always the longest side. Now these two sides over here are called the legs. Okay, and when we're dealing with angles, we can kind of use these words of opposite, hypotenuse, and adjacent to talk about the lengths of these sides or these legs. So, for instance, if I'm looking at this triangle over here, this is a little example just to show you, and this is angle A, okay? If I look across the triangle, this is my opposite side. Think of looking at a classroom across the hall. If I were looking at my adjacent side, that's the side that's connected to this angle, okay? That would be the classroom next door. And then the hypotenuse is always the hypotenuse. Okay? So be very careful when you're trying to determine what is your opposite side or what is your adjacent side. So opposite would be like across the hallway, adjacent would be right next to the angle. So let's talk about these trig ratios. So we have some trig ratios here, and we're going to write them out fully. And then again, you can always go back up to the top. You can, back up the video a little bit, pause it on that screen, and you can write it down from there too. So first ones that we have, these are our regular trig ratios. We have sine, we have cosine, and we also have tangent. Now to find these, and we're going to also shorten these into their regular notation. So if we're trying to find sine of theta, which is just the angle measure, it's going to be the opposite over the hypotenuse. If we're trying to find the cosine, so this is cos of theta, that's going to be the adjacent side over the hypotenuse. And then we have our tangent of theta, and that's going to be the opposite over the adjacent. So these are our basic first three trig ratios. They also have the reciprocal functions. So the reciprocals have a different name as well. You want to be careful with which ones are partnered up. So right now we're looking at sine. Its reciprocal function is going to be called cosecant. So this is going to be called cosecant, C-O-S-E-C-A-N-T, cosecant. Now cosecant gets shortened to CSC, and CSC of theta is just the reciprocal of the sine of theta, so it's going to be hypotenuse over opposite. Okay, now we can move down to cosine. The reciprocal of cosine is secant. That's going to get shortened to SEC of theta, and that's going to be the reciprocal of cosine. So this is hypotenuse over adjacent. Now our last one kind of makes the most sense. It's called cotangent. That's going to get shortened to COT of theta, and that'll be the reciprocal. So it's going to be the adjacent over the opposite. So this is set up to the fact where you can remember your sine, cosine, and tangent. You can also figure out these three values without having to memorize this, okay? So the thing that you can use no matter what is called SOHCAHTOA, and you might have heard of this. So we have SOHCAHTOA. And when we're looking at this, you can see this is telling us sine is the opposite over hypotenuse. Cosine is the adjacent over hypotenuse. Tangent, opposite over adjacent. So this phrase right here is telling us everything that we see right here. Sine is the opposite over hypotenuse. Cosine is the adjacent over hypotenuse. Tangent is the opposite over adjacent. So let's use this theory in a few problems. So this problem is directly from Delta Math. In this problem, you can see that they're giving you a lot of information. They're telling you it's about a triangle, but you don't see a triangle. So I always suggest to draw the image first. So we're going to draw this image first. We know that this one's a right triangle because if you look, it's telling you that the angle of W is 90. Okay, so that was the first piece of information that I noticed, was that the one angle measure they gave us was 90 degrees. So it's a right angle. So now when you're trying to place the U and the V, you can see that if we're following the order of our title of our triangle, it's U, oops, let's change that. It's U, V, and W we already have. So we can fill in some information here. They're telling us that the side length UW is 35. They're telling us that the side length of VU is 37. And they're also telling us that WV is 12. So we have enough information here. We're trying to find the tangent of the angle U. So tangent of U, we're not sure what it equals, but we're going to be able to find it. When you are getting triangles or getting any image set up, you do want to just double check yourself as you're going. Your longest side should be your hypotenuse. So if somehow you set this up and you have a 12 over here, that should be a red flag that this is wrong. Okay, your longest side is your hypotenuse. The other two legs can be whatever they want, but just make sure you're setting it up correctly. So thinking back to SOHCAHTOA, remember it ends with TOA, which means that tangent is the opposite over adjacent. So we can fill in our opposite side. So I'm going across the triangle. So we have 12. And I'm going to divide it by my adjacent side, the one that's right next to it, so 35. Now this problem is asking for our value in the nearest hundredth, which means you're going to need a calculator. So we're going to have the tangent of U equals 12 over 35, and you can just divide 12 over 35, and we're going to get 0.34.